sector area now. A sector area is a piece of the area of the circle. And we're going to use a proportion just like we did on the arc length part. Or of course you can use the fraction times the area. It depends on what you're having to solve for. If you're having to solve for something like the radius or the area of the whole circle, using the proportion is easier. And I like to just use one method, so I always go with the proportion method. We're going to find the area formed by the angle RQS. This is a central angle. The measure of it is 63. That is the part of the degrees, which the whole degrees is 360. The part of the area is what we're finding, and the whole area is 25 pi, because the area of a circle is pi r squared and the radius is 5. So we have it set up, and we're just going to cross multiply and solve. So 25 times 63 will give me 1,575 pi, 360x. Then we're going to divide by 360, giving me 4.375 pi, 4x. And typically they're going to ask you for a decimal value, so 13.74. If you go ahead and put pi in there, and that would be units squared, and they didn't have a unit on that radius, so just put u squared. Here we have a radius of 8 centimeters. This angle is 60 degrees, but the shaded part is the rest of it. So we have to think about how a whole circle is 360. Take away that 60 there, we have 300 degrees that we're working with. So 300 out of 360, part of the area over the total area pi r squared, r is 8, so 64 pi. So 64 pi, and what you could do, you could reduce the fraction. This fraction reduces to 5/6 to make some nicer numbers for us to use. 64 times 5 is 320 pi. 6 times x, divide by 6. 53 1/3 pi, or multiplying by pi, you get 167.6 centimeters squared. Over here, we want to find a segment. It's kind of weird how this is called a segment. It's like a piece of the area formed by, this is called a chord, and the edge of the circle. And so what we're going to do for this is we're going to do the sector area minus the triangle. And so it's 90 degrees. So this sector area, 90 over 360, piece of the area over the total area of the circle would be 36 pi, because the radius is 6 and pi r squared. 90 over 360 reduces to 1/4. It's a fourth of the area. So we get 36 pi equals 4x, dividing by 4, 9 pi. So 9 pi is the piece of the area of the circle. We're going to subtract from that the triangle. Triangle area, we know, is base times height divided by 2. So these are both radii, so they're both 6. So 6 times 6 divided by 2 is going to be 18. So 18, so 9 pi minus 18 meters squared is the area. In exact form, that would be how you would write it. And if you plug that into the calculator to get a decimal, you would get about 10.3 meters squared. One more. We have this one, and to do the area of this one, what you're going to want to do is the sort of Pac-Man shape there, plus the triangle. So the Pac-Man part of it, 300 degrees of the circle there, so 300 over 360, x over 144 pi, because 12 is the radius, so the area of that circle would be 144 pi. And cross multiplying and simplifying, you get 120 pi for x here, so 120 pi is that portion of it. And for the triangle, so I'm going to draw this as the top, and this as the bottom. And I'm going to redraw this triangle. So that's 60 right now at the top, and 12 centimeters here. Notice that these are both radii, so they're both 12 centimeters. So this is an isosceles triangle. And you might notice having a 60 at the top is actually equilateral, but I'm going to just act like it's isosceles. I'm going to drop in the height, which will bisect this angle. It will also split the bottom evenly. So I have a 30-degree angle at the top and a 90-degree here, which makes this a 60 degree. So I have a 30, 60, 90 with a 12 for the 90. That means that the 30 will be a 6 and that the 60 will be a 6 root 3. And so that makes the base of the triangle 12 and the height of the triangle 6 root 3. So for the triangle area, we're going to do base times height divided by 2. So this is going to give us 36 root 3. So that'd be centimeters squared. So this would be the exact form of the answer. And if you wanted to approximate that to a decimal, it would be about 439.3 centimeters squared.